All right, so today we're going to talk about writing a graph given, writing an equation given a graph, okay? And before you do that, we need to review some vocabulary words as always, okay? So the first thing I want to review is what roots mean, okay? Because you need roots to make your equation. Your roots are your x-intercepts. They're where your graph crosses the x-axis. So if you look right here at this graph, my roots are where it crosses the x-axis, okay? And those are your solutions also. Roots are also called solutions, okay? So we're going to use our roots to help us form this equation. Now, these roots have something called a multiplicity, okay? A multiplicity is that little exponent with each factor, all right? So if the graph crosses at that zero or solution, then we have an odd multiplicity. If it touches, we say it has an even multiplicity. Now, what does it mean by cross or touch? So look down here at this graph. See how right here, number one, we're going to label number 1, 2, 3. When it crosses, see how it just crosses across that axis? That's a single zero. It has a multiplicity. Now, for us in this class, that means that's going to have a multiplicity of 1. So it's going to be like x minus 0 to the first power. Okay, that little 1 right there is the multiplicity. In graph 2, you see how the graph just goes down, touches the x-intercept, and comes back up. That's going to be an even multiplicity. And for this class, 9 times out of 10, it's going to be a multiplicity of 2. So we would write it as x minus 0 squared. Okay? Now, this is a special case, number 3, and it's only if you see it just like this. If there's no other zero, so if there's no other zero and your graph kind of crosses it and lays at that zero a little bit like that, we're going to say this is a cubic multiplicity. That's only if that's by itself. Okay, it can't have any of these with it. Okay? All right. In the last picture with the black background over here, it gives you an example. See how it crosses at positive 1? Multiplicity of 1. See how it touches at positive 4? Multiplicity of 2. Okay? Now, we've talked about getting your roots from the graph, but how do you convert those roots to a factor? Okay, so to convert those roots to a factor, you first find your roots, find out what your roots are, x equals, list them out, and then you convert them to a factor form by using this, x opposite a, because remember, a minus doesn't mean a minus with a letter, it means opposite, okay? So you're going to change the sign of your factor when you put it into factor form, okay? Having issues with my charger. All right, so steps. Step 1, write your factors. Step 2, find your multiplicities. It's a long word. 3, solve for a. Okay? All right. So, let's do these 3 steps. Write your factors. We got to get them. It's x equals negative 1, x equals 2, and x equals 4. Remember, it's opposite a, so my factors are going to be, we're going to say y. Let's change color so you can, I really hit my laptop. We'll stay charged. There we go. All right. So, we've got y equals, change the signs. X plus 1, x minus 2, and x minus 4. Get your multiplicities. It touches at negative 1, so that's an even multiplicity, and you're going to use a 2 for that. It crosses at 2, and it crosses at 4, so that's multiplicity of 1, so we leave it alone, because you don't write an exponent of 1. Okay? Now, we know that there is an a value in every equation. Okay? Any polynomial we've written, remember, quadratic was ax squared plus bx plus c. There's an a. Linear, ax plus b. There's an a. Okay? Cubic, same thing. There's an a value. So you now, when I give you a graph, you have to solve for your a value. So really my equation looks like this. All right? Now, in order to solve the a value, you know you can't have this many variables, so we need to have an x and we need to have a y. So on your graph, usually they give you the point. Okay, you can't use your zeros. I mean, you could, but they say to use another point. So we're going to use another point. But we're not going to solve it for on this one because it doesn't give me a clear point. Okay? But the last step would be to solve for A. And we're going to do that in our next examples. Okay? All right, let's pull them up. All right, so example 1. Now, we're not going to worry about standard form yet in this class. In this class we are. But it's going to be in the next unit when we do polynomial operations. You'll figure out how to go from factor form to standard form. Okay, so we're going to stick with factor form. Okay? All right. All right, so I snipped it because I thought it'd be easier to do it with on a clear to show my work for A. All right, so step 1 is to get your factors. We've got -4, -1, and 3. So I'm going to write this as y equals A, x plus 4, x plus 1, and x minus 3. Get your multiplicities. Well, these all cross, so they're 1. So now I need to solve for A. Do you see how this gave me a point down here? That is your x and that is your y. You're going to plug that into this equation and you're going to solve for y. Okay? So when I plug this in, I get y, which is -36, equals A, 2 plus 4, 2 plus 1, 2 minus 3. We're going to simplify. Okay? -36 equals A, 2 plus 4 is 6, 2 plus 1 is 3, 2 minus 3 is -1. Multiply these 3 out. You're going to do the same steps every time. Okay? So 6 times 3 is 18. 18 times 1 is -18. Okay? We're going to divide by -18. And -36 divided by 18 is +2. So my equation here is y equals 2x plus 4, x plus 1, and x minus 3. Okay? And that's it. That's all I got to do. All right, let's do another one. All right, so this one, same process. Get your zeros, okay? So my zeros are -5, -4, and 0. So write it in factor form. Y equals A times x plus 5, x plus 4, and x plus 0. Now, do I need that plus 0? No, you don't, okay? I just get rid of that plus. You don't need the plus. I just have the x, and I move that x to the front just for aesthetic reasons. So y equals ax times x plus 5 and x plus 4, okay? Now, gave me a point again. Here's my x and y. -3, 2. My y is 2. And I'm going to plug my x. I'm going to plug -3 into all my x's. Okay? So now I have, so simplify this, okay? It's -3. -3 plus 5 is 2. And that's going to be 1. So 2 equals A. Multiply these. -3 times 2 is 6. So it's -6. Divide by -6. Just reduce this down. Don't get a decimal for A. Okay, A does not need to be a decimal. So this reduces down to 1/3 negative, and that equals A. So my final equation would be y equals -1/3 x times x plus 5 times x plus 4. And that's your answer. Okay? All right. Let's do another one. All right, let's do this one. All right, so find your roots. -3 and 5. So I've got y equals A, x plus 3, x minus 5. Well, it touches at -3, so that gets a squared, okay? And then it crosses, so that stays 1. Now, this one doesn't give you a point, but it has good enough grids where you guys can find a point. And if you look, I have a point right here, the y-intercept. And it's going to be 0, 90. We can use that, okay? X is 0, y is 90. This one should be easier. So we're going to plug it in. 90 equals A, 0 plus 3 squared, and then 0 minus 5. So simplify. 0 plus 3 is 3. 3 squared is 9. 0 minus 5 is -5. Keep simplifying. 9 times 5 is negative 45. Divide by negative 45. And 90 divided by negative 45 is negative 2. And that's my a value. So my equation will be y equals negative 2, x plus 3 squared, x minus 5. And that's your answer. All right, last one. So we're going to get our roots. We got a root at negative 1, 4, and 6. Let's write it out. Y equals a, x plus 4, or no, I'm sorry, x plus 1. X plus 1, x minus 4, and x minus 6. They all cross, so they have a multiplicity of 1, so we don't need any exponents. I get my point. My point is 3, negative 36, so I've got negative 36 equals a times 3 plus 1, 3 minus 4, 3 minus 6. Okay, simplify that right-hand side. It's going to be 4, negative 1, and that's going to be negative 3. Okay, simplify it some more. 4 times 1 is negative 4. Negative 4 times negative 3 is positive 12. Divide it by 12, and that's going to be negative 3 equals a. So my final answer is y equals negative 3, x plus 1, x minus 4, and x minus 6. All right, so I'm going to make a video to help you do a couple Delta math problems too, but that's it for this lesson.